Today, class is about software testing of the Introduction to Software Engineering course. Testing is about another process, a process in the software process that we have to consider to developing kind of software. There are many topics that we have to discuss about software testing. By default, by normal, when we talk about software testing, these words will appear to you. For example, as fault, failure, defect, and error. This is a kind of thing that we want to avoid. We want to we want to avoid to make this thing happen. Okay. That's why we need to do software testing to make sure that our software is working correctly according to our requirement and specification. Software testing, you look at the layers, we can see there are testing in a process. We have a process, software testing process, and then we have software testing method. Okay. In software process, software testing is the third, is the fourth step, testing after we developing the software, we call it development, and then we have to test the software before we deploy to the real environment. Before we make our customer use the software, we have to test the software first. In this lecture, we want to talk about software testing that include four topics. The four main topics. There is development testing, test-driven development or TDD, and release testing and user testing. Let's we talk one by one. The main point of the software testing is intend to show that the program does what it is intended to do and to discover program defect before it is put into use. It means that we want to discover, or we want to show the program is working well without any defect or without any error before we deploy the software. That is the main thing of the software testing. We want to make sure that software that developed software is working well, before we release the software. When you test software, you execute a program using artificial data, because we have no any real data from user, so we will use the artificial makeup data to test our software is working correctly or not. You check the result of the test run for errors. This is the word that we familiar, errors, because when a software not working well according to the requirement or specification, it will show some errors. And then we call another word we have anomalies. Anomalies mean abnormal things happen to our software. The software testing can reveal the presence of error, not the absent. So it means that it will show you a thing that the error that present in your application, not something that absent. Something that is not absent, it not be detected by the software testing. Testing is a part of more general verification and validation process, which is include static validation techniques. The software testing is a part of we call we and we, or verification and validation process. Two main things of the software testing goal. There is to demonstrate to the developer and the customer that the software meet its requirement. This is the first goal, and the second goal is to discover situation in which the behavior of the software is incorrect, undesirable, and do not conform to its specification. We do testing. First is to check that our software is meet the requirement or not. This is the first, and then the second is to discover situation. Our software is working correct or not. This is two main goals of software testing. the goal is we can the first goal lead to validation testing. The first goal of the software testing that we discussed is about validation, to make sure that the software is meet the requirement of the user and system. And the second goal lead to defect testing. It will check the error inside the software itself. Okay, we call defect testing. Testing process goals. Okay, we have two testing process goal. There is validation testing and defect testing. Okay, the validation testing to demonstrate the developer and the system customer that the software meet its requirement. This is the main point of the validation testing. Actually, we will look back to the requirement of the system, and then they see that the software is meet the requirement or not. This is the validation testing. Defect testing is to discover fail or defect in the software where its behavior is the incorrect or not in the conformance with its specification. The main point of defect testing, we try to discover a thing that abnormal in the software. This we call defect testing. Okay. In software, we have to have the input that we use to test the software, and then we will have the output that we will see the result in terms of output. So here we have input test data and a system that we testing, and output test result. So in the system, we use the input test data, whatever criteria or test case or scenario and so on. We use it to be as the input test data, and then we test the system, and then we will the system according to our testing result. It will display the result according to our testing input, and they will display the result, what kind of the result of that test. Okay, it will be pass or error or defeat or something else. Okay, verification and validation, the two main things that when we discuss about software testing, because software testing is a part of verification and validation. Okay, verification, the short meaning of verification is, are we building the product right? And then the validation is, are we building the right product? The another specification or meaning is that for verification is the software should conform to its specification. It means that the software should be meet the requirement. Okay. For validation, the software should do what the user really requires. This is of the validation, that the software should meet the requirement of the user, exactly what the user needs. Sometimes we create a software that meet the verification but not meet the validation. Mean that we create according to the requirement of the user. Then the user doesn't need that function, so it cannot be meet the validation. This is the difference between verification and validation. Okay. V&V model. Okay, this is we call V&V model. The main purpose of the V&V model is fit for the purpose. We want to do verification and validation to make sure that the software is meet or fit for the purpose. What kind of purpose? A software purpose, user expectation, and marketing environment. This is purpose according to the system and user expectation and marketing environment. So we develop some kind of software, and then we have to make sure that the software is meet or fit to the purpose. According to here, there are software purpose and user expectation and marketing environment. For example, in the software purpose, the level of confidence depends on how critical the software is to an organization. The user expectation, user may have low expectation or certain kind of software. Getting a product to market early may be more important than finding defect in the program. So we try to do validation and verification to make sure that our software it meet the purpose. Okay, the software is working well, but they do not meet the user expectation. It will be not something considered. Okay, and then it may be marketing environment. For example, you want to release software quickly, but you do a lot of testing. It will be you will release the software will be lately, right? Will be late. So you have to consider this thing. You don't want to do test software testing, because of the software testing is time consumed and using a lot of resources, especially budget and manpower to do this one. Okay, that's why many software they try to avoid to use what we call software testing, but it is necessary to do software testing, because of we want to make sure that our software is working correctly according to the requirement and specification. Inspection and testing. Software inspection concerned with analysis of the static system. Software testing is about concern with exercising, and it related to dynamic verification. If you look at inspection, if you are using the text editor or code editor or IDE, the code analysis is we call inspecting. You look at the code, the software, the component, and then you see some kind that represent some red error, something over there, we call code analysis. This is static one. There is not what we call dynamic. It means there is not response and request and response or interactive between the tester. Okay. For software testing, it concerned with exercising. It means that it's related to dynamic verification. It will interact with the tester. Okay. Actually, we have to do the test. We have to use input and test data to have the operation to the software testing. Okay. You can do software inspection easily by using any kind of editor. Okay. Then you can do highlighting, checking the error, and so on over there, and then you can debug according to the error. For software testing, you have to run the test. Okay. You have to write the code and then test according to its behavior, according to its input and scenario, and so on. For example, here is comparison between inspection and testing. Inspection can be applied to any process. Okay, can be applied to requirement specification, software architecture, UML design, model, database schemas, and program. But for testing, okay, we actually testing the program. Okay, we're testing the program only. Okay, to see the code is running well or not. Okay, without any failure, debug, and defeat. Software inspection. This involve people examining okay the source representation with the aim of discover anomalies and defects. Actually, we do the software inspection to see the code inside the source. We call the source representation. To see something abnormal, we call anomalies or defect. Okay, this is we call software inspection. Inspection not require execution of a system. We no need to execute or compile or run or interpret the software to do the inspection, because inspection can see by the inspector. Okay, see that is something it error before it implement or not. So may be used before implementation. We can do the inspection before we can implement the coding. Okay, they may be applied to any representation of the system. As I say, the requirement, design, configuration data, and test data. Okay, they have been shown to be an effective technique for discovering program error, because we will use software inspection to inspect something before the software is executed, so we can find the error before it's software running. Okay, before we execute the software or compile the software, so it can be reduced many defect and error. Okay. Advantages of inspection. During testing, error can mask high order error, because inspection is static process. You don't have to be concerned with interaction between error. So you will look at the code or the resource, and then you can inspect before it runs, so it can be reduced the error. Okay, incomplete version of system can be inspected without additional cost. For example, we want to combine too many components together. Okay, so this will be a lot of cost to combine it. So, and then if we are implementing the inspecting, we can see that how it combined before we can deploy to the real environment. Okay, if a program is incomplete, then you need to develop a special test hardness to test and the part that are available. If something that is incomplete, so we had to test it first before we combine or we merge the component together to be a system. Okay, as well as searching for a program defect, and inspection can also consider broader quality attribute of a program, so such as compliance with standard, portability, and maintainability. So we can use the inspection to find the defect before it can it can be occur. Okay, it can be occur. Inspection and testing. Inspection and testing are complementary, means working together, along together, not opposite verification technique. Okay, both should be using during VV process. So we want to do testing, so we have to do inspection first, and then we can do this testing, or you can do testing and then you can do inspection. Okay, most of inspection is done by human being. Okay, by human being. Testing also can be done by human being, but the testing can be automatically, but inspection can be by manual because it's static. Okay, inspection can check conformance with specification but not conformance with the customer real requirement. It can be check something that the specification or the requirement specification, but to see the real result we have to compile first, because inspection we no need to do compile or execute the program before we can do the inspection, but the testing we have to compile first and then we can test the software. This is that's why they say the inspection can check conformance before it cannot be check the customer real requirement. Okay, inspection cannot check non-requirement characteristics such as performance and usability, because the code that using the inspection we don't execute, right? So we cannot see the real situation happen over there about performance and usability. You can see that just only resource, for example as code, right? You see the code that are error over there, they may highlight by red or yellow and something so on. So we just detect something like that, not such a performance and usability, because the performance and usability is we will test after the application is run already or execute already. A model of the software testing. There are many models for software testing process. Okay, this is the generic process for software testing. Okay, first we design test case. Okay, the test case, it can be what you will start from A, B, C, or B, A, C, or so on. Okay, and then you prepare the test data. Okay, what data you want to test. Okay, especially we use artificial data. You can generate by using a tool, the automatic tool such as JUnit, okay, PHPUnit, and so on. And then we run a program with a test data. Okay, and then we compare the result to the test case. Okay, and then we report. This is the software testing process, generic software testing process that we have to apply when we want to do software testing of any kind of software or program. To do testing, there are many levels of software testing. Okay, here they compose of three. They divide to be three levels of software testing. The first is development testing, the second is release testing, and the third is software user testing. Okay, development testing is about discovering a bug and defect actually. Okay, release testing is about when we want to release to our software, we do this thing. Okay, to make sure that the user or the team member of user who use the software will test the software. It will working according to its requirement or specification or not. User testing is about we release to the user, the real user who use the software, and then they will what we call feedback to us about the testing result or something called bug or errors and so on. Okay, we can see here there in the development testing we are actually is done by the programmer. Okay, or if in a large software team there may be another group of people that is we call software tester. Okay, but if you are developing a small application, so the development testing will be done by the programmer itself. Okay, release testing will be done by the team member, or maybe a team member of who take care about the quality of the software. Okay, And then the user testing is about the real user, okay, who going to use our the software, okay, the program. They will use the software and then they will reply back the feedback to us according to they found what kind of error and so on. Development testing. The main point of development testing is they're done by the team developing the system. Okay, the development testing include all testing activity that are carried out by the team developing system. Okay, there are 3 levels of development testing. There is unit testing, component testing, and system testing. Unit testing, they are related to testing the unit or object inside the class, okay, inside of the class or function of the class or the method. Okay, component testing is related to testing the component itself through the interface. Okay, because right now most of code is they are coding based on the code to interface. Okay, they provide just only interface to you, and then you wanna use that code, you call the interface and you use it. This is we call you wanna test that component, so we have to use a component testing. Okay, or if you are developing the huge or large system, better to develop by using a component, and then we have to test a component is it working well or not. Okay, system testing. After we have many components, okay, so after we integrate, okay, integrate all components together, become a system. So we have to test the system that all component or any component that related to each other working well. This is we call testing, system testing. Okay, if we go one by one. Okay, this is the software testing level. Okay, we have unit testing. This is a small part. Okay, unit is very small part. So you test your object or your class or your function within a class. Okay, this we call unit testing. Integration testing is about the component, right? The working between a component is working or not. If you're calling another component and then you will test it's working or not. System testing is about all components working together, merged together to be a system. So we have to do testing. Acceptance testing is about the user that will accept or not the system. Okay, this is we call acceptance testing. There is acceptance testing is done by the black box. Okay, the user will use your application and they will report to the developer or the project manager that is the test is how many level, how they are satisfied with the test result or not. Unit testing. The unit testing is the process of testing individual component in isolation. It means that it will test just only a small part, okay, a small part of the application. It is a defect testing process. It tries to find the error or the default what we call fail value inside the application. Okay, unit may be individual function or method within an object. Okay, because according to the real world. Right now they are developing based on object oriented. Okay, so unit testing can be testing individual function, right? Function inside or method, another name, same thing. Okay, within an object. Okay, object class, it can be unit testing can be test the object class within a several attribute and method. In the object class we have attribute, right? We have many methods, so this is a kind of testing. We can use unit testing to test the attribute and method. Composite component which define interface used to access the functionality. So one class may depend on another class, right? So we had to test this one also by using unit testing. Can done this one. Okay. Object class testing. In class, right, we have object and that, right, that represent in terms of object, and then that the class is the overall of behavior that include class name, class property, and the class method, right? So to test the class, we have to test this one because the class is small part. Okay, the small part of the application. Okay, the complete test coverage of the class involve testing all operation associated with an object. Okay, that the thing that associate or operate to the object. Okay, setting and interrogating all object attribute. So there are something that working within the object attribute, so we have to test, okay, to make sure that they are past the condition that we set by the test case. Exercising the object in all possible states. So we try to exercise, we test the object in all possible states, okay. We try to do something, make it fail, make it run, make it something abnormal, that the test that object is can be defend, can be handle the situation according to the test case, okay. In the object oriented, we have inheritance. Because of inheritance is inherit or depend on another object, okay, depend on another class. This is very difficult for software tester to test, because it's not in because it inherited the class and the property and method is not from itself, from another. It will be difficult for software tester to test. It may got some what we call unexpected result according to this, okay. For example, here is the object of weather station interface, okay. We have the name of the interface. You have the name of class is weather station. We have identified as property, and then we have the interface name, report weather, report status, and so on. This is the interface. So if we want to test, so we have to call this test, and then we pass the parameter and so on to test according to the test case. They will meet the criteria of test or not. If they can meet, so the test is passed, okay. So for example, this one is we can use the test case, okay. The test case means that what thing you will start, and then what situation or what condition you will test the object, okay. For example, here we have for testing the weather station, right. We run shutdown, running, shutdown, okay, configuring, running, testing, transmitting, running, something like this, okay, running, collecting, running, summarizing, and transmitting, and running, for example. This is the test case that organized by the software tester, that what the sequence that we wanna test the object or the class, okay. If there can be past this condition, it means that the test is success, okay. Automated testing, okay, or automate testing. We don't want to write. We don't want to run again and again by ourselves. So we want to make the test can be run by itself. For example, okay. So we have to use some kind of framework, okay, to help us. Here we have many framework according to the application or programming itself. For example, in PHP we have JUnit for unit testing, okay. In Python we have unit test. This is for Python, and then in PHP we have PHPUnit to write the automate testing. Why we need to do a unit testing, okay? Because why we have to do automate testing? Because automate testing can help us to reduce our effort to run the work every time we want to test. It can be done by itself, okay. It can be a collection, and then it provide the interface and the a class that can be used to help us to achieve the test very well, okay. That's why we have to use a framework, okay, a framework. In the automation framework such as JUnit, unit test, or PHP test, they provide generic test, okay, general test that you don't need to write by yourself. You can call and use the test, and then test your application, that your application meet the certain or meet that condition or not, okay. Automated test component, a test, a setup part, a call part, and then an assertion part, okay. We have to set up what the condition we want to test, and then we call part. We can call object and then test, okay. And then the assertion part is we compare the result that we get from the result that we get from the evaluation process, and then we can see this is fail or success, okay. This is the process of doing the automate test for the component, okay. First, set up the part, which part you want to test, okay, because in application there are many parts, right, okay. So and then you call a part, okay, call a method or call a function or call a property to test, and then and then they will sort apart. It means that they will display the result of the test, and then you compare the it will success or fail. Okay. Choosing unit test case. There are many test cases that can be run for testing. Okay, for many run for testing. The test case should show that when you use expected component that you are testing does what it's supposed to do. You have to choose a test case based on if you have the list of requirement. For example, if you have requirement already for example login, you have the object about login, so the test case it should be about login, right? It should be handled username, password, and so on. This is we call the test case. Okay, start from entering the data and then submitting and then processing and then return the result, return the message that you are successful login or not, and then you can write the test according to the scenario. Okay, the main point of unit test case is to reflect normal operation. This is the normal thing. We want to test that the operation is working well or not. Okay, and then the second is common problem arise. Mean that when we test, we want to find the error inside the application. Okay, this is the main point of unit test case. Okay, the first is reflect normal operation. So we want to test to make sure that the application working normally according to the programmer write the code, right? And then the second is to find the problem inside the application or the component. We call defect testing. Okay. Testing strategy. We have two strategies for testing. The first is partition testing, and the second is guideline testing. In the partition testing, where you identify group of input that have common characteristic and should be processed in the same way. So if you have the group of the requirement or the group of input that you use to test the same thing, so you can group to be partition. Okay. For example, you may test many features. Okay, we have 10 features, but they are sharing the same characteristic. You can grouping to be apart. Okay, we call partition, and then you can test. You write one, for example, you have 10 features, you may write just only 3 or 4 test cases, and then you can test. This is we call partition testing. A guideline based testing, where you use testing guideline to choose test case. There is a guideline over there. There are many people propose the guideline that you want to do, finding error, finding defect in the application. There are guideline 1, 2, 3, or 4, 5, and so on. There are many. So you can choose over there to do it. Okay, this is two strategy. Okay, mostly if you are starting the beginner, the better by using the partition testing. Okay, if you want to move to a little bit more advanced, you can use guideline based testing. Okay, here is partition testing. The partition testing, they require input and the output result will represent to you. You have to use input data, and then the output result will present to you. Okay, you can group the same testing test case to be one, and then you can test for several features. Okay, the test case, each of these classes in equivalent partition or domain where the program behave in equivalent where each class member. Okay, test case should be chosen from each partition. This is example of equivalent partitioning. Okay, we have input. For example, we have input here. We have input 1, 2, 3, 4, 5, right? And then the possible input that can be test the system, and then it will be output the partition. How many output can be available over there? For example, you have the one feature 1, and then you have test case 1, 2, 3, 4, 5. There just only 2 test case can be what we say the correct output. This is we call equivalent partition. You have to write many the software tester have to write many testing software, okay, testing condition, and then they will test through the system, and then they will see the output. That is how many condition or main test case will pass in the correct output of the testing. Okay. This is also the equivalent partition. They try to divide, okay, according to input, okay, according to input, and then they will display in terms of the output, okay. Testing guideline. Test software with a sequence which have only a single value, okay. Because the partition they test by many value, okay. The testing guideline just only represent just only one single value, okay. You wanna do testing, for example, you are doing testing in PHP. The framework that used to any programming language, okay, any programming language you wanna do testing, there are two over there framework. Don't try to write your own code from the beginning, okay. So you have to find some kind of framework and learn from that framework. It will save you a lot of time, ton of hours, okay. For example, here this is my personal choice. There are many over there, okay. There are many. This is a framework, okay. This is a framework. If you wanna start, you can start by using the JUnit. Also is available. Sorry, PHPUnit, okay. You are using PHP. We call PHPUnit this one. A unit testing framework for PHP programming language, okay. It used to test as a slide presentation. I showed to you that unit testing is used to test the what we call class, right? Object and method and property over there. We use this one to test, okay. Right now, unit testing can be test also the component through the interface. Component interface. You can go and check my video on YouTube about software design. We call component interface. It will look like this, okay. This is the application you're running, okay. You try to create and then you provide some interface for you. For example, you create interface in MLP. In MLP, I try to create interface of that database connection, right? Okay, so you wanna test, you wanna use, you call the interface to use it instead of the coding inside itself, okay. This is another example. You see, object 1, object A, B, C. Okay, they provide the interface. Okay, you have no permission to editing something inside the code, right? But you can use call to use the code. Most of code nowadays, most of framework nowadays, they design to be like this. Okay, to be like this is the interface. So if you wanna use a framework to test, so you have to know how to use the interface, okay. Code today is they are based on interface. You call and use it, okay. We are talking about PHP. We are talking about unit testing, right? Okay, unit testing. This is you are using PHP. This is the framework that used to that created by the PHP itself, okay. PHP itself. You wanna go more beyond than that, you can use Codeception, this one, okay. They provide much more tool, okay, that used to test. You don't need to write the code by yourself, okay. And then you can use what we call artificial data. Artificial data, you don't need to thinking by yourself. They are providing for you, okay. We call Faker, okay. They are the tool that over there we call Faker to generate the data, and then you can test, okay. For example, this one, okay. They provide you example here. You see the example here. They try to show you that in the what we call $sign I, right? And then M on page, click C in database. If we see that if you run this one, is it working or not? Okay, this is we call test. You have the code over there running already over there, and then you deploy the code already. So you want to make your code is to test, okay. Especially without test. So what you have to do, you upload your code, right, and then you let the user try to use the application, and then they found the error, okay. This is the trouble thing. before they found the trouble. So we have to find that trouble first, okay, and fix the error. We don't want to upload or release our software with any kind of error, okay, to the user. So we have to do testing, okay. This is the main point of the testing. This is Codeception. This is a framework testing framework for PHP, okay, for PHP. Then many application what we call framework use this one. For example, Symfony use this one, Laravel, WordPress, Joomla, Yi, Falcon use this framework, okay. Use this framework for testing. If you want to learn about testing, you can come to here about Codeception and learn this one, okay. You don't need to write by yourself line by line and so on. You can use the framework over there. But the thing that you have to understand is the principle, the concept, okay, the vocabulary, okay, the vocabulary that about the testing. For example, unit testing, component testing, system testing, acceptance testing, and so on. What is about, okay, how it can be done. When you want to apply in the real world, you can use any kind of framework, okay. First, to learn anything, okay, you have to understand the concept, okay. This is the main point or principle we call. Then this is a tool that I say to you, Codeception, okay, a tool, okay. Just only two, one of 10, one of 100 tools that are available for you to use for testing, okay. But to understand this, the kind of testing, how many kind of testing, how they done, vocabularies about testing, you have to learn about the principle, okay, the concept. If you learn about, for example, Codeception today may be familiar, may be famous, but tomorrow may not. For example, if you learn about concept, the concept over there, 100 years, 200 years, still over there, okay. For example, you learn religion, right? About religion, you learn about something that the question the people on the 13th century, right? They may asking another question. We are asking about Bitcoin, for example, blockchain. What is the Sharia say about blockchain? On the 13th century, there is no such Bitcoin and blockchain, right? How to answer this one? What you have to learn? You have to learn Quran and Hadith, right? Fiqh. To answer this one, the main concept is Quran, Hadith, and Fiqh. This is about we call a concept and principle. The tool is how to make the fatwa about such what we call Bitcoin or blockchain, right? That's why if you want to learn concept, it can be you learn one, you can use for whole life. Testing guideline. There are a test that used to a guideline that used to guide the testing. Okay, the test software in the sequence which have only a single value. Okay, use a sequence of different size or in different tests. Derive test so that the first, middle, and last element of the sequence are accessed. Test with a sequence of zero length. This is a kind of another testing strategy we call guideline based testing. Okay, a guideline can be represented for many forms. Okay, they can be represented by many guidelines. This is one of another guideline that can be used for testing in guideline based testing. Okay, this is a guideline that we want if we want to use about testing by using under the unit. Okay, unit testing. Okay, the small part is class testing. You can use this one as a guideline for testing. Okay, the first is choose input that force the system to generate all error message. Okay, you by using guideline strategies, so you have to choose the input that you think that this input can make the system generate a lot of error message. And then we can see the message what kind of error, and then we can fix the error. Okay, design input that cause input buffer to overload. We try to make the this is we call defect, okay, defect testing. We wanna test our application that how it can be handled, okay, how much it can be handled, the overload, okay, or the buffer, okay. So we have to design something that try to inject, try to test, try to inspecting that how our system can be handled, okay. Repeat the same input or series of input numerous times. We repeat again and again to see what the error the system will show to us. Force invalid output to be generated, and then we try to firstly we for input incorrect input, right, and then we have to force the invalid output, okay. We try to make our application generate some kind of unaccepted or invalid output. What the kind of invalid output that they will present, we will see that, and then we can fix our system, okay. Force computation result to be too large or too small. So we have to, for example, we try to upload some file, right, that is more than, for example, our application can be handled just only 2 megabyte of file, right. So we try to upload 100 or gigabyte the file that can be compute or not, something like that. So this is, we try to make uncertain condition, something that unexpected sequence or guideline to test that the system, how the system can be handled, what the output and what the input of the system will display to us, and then we take that output to fix and then to debug our application to make it much more better in terms of software testing. Okay, we talk about unit testing. Okay, the unit testing is focusing on testing the class or object or method, property or function, right. There are a component testing, another level of testing, okay, we call component testing. The software components are often composed of components that make up several interaction objects. In the software component, there are many objects, okay, there are many class inside, so we have to test it also, okay. We have to test it also because in component there are many function inside, right, to make their interaction between object, okay, interaction between object. We want to make sure that the interaction is correct, okay, without any error, okay. For example, in the weather station system, the reconfiguration component include objects that deal with each aspect of the reconfiguration, okay. They are dealing with many another objects, so we have to make sure the object is working correct according to the criteria, okay. You access the functionality of this object through the defined component interface, okay, because a component, most of component code right now, they are trying to coding based on the interface, okay. They do not allow you to access to the method and modify the method, but you can access and then use the method, okay. So we have to test the component interface, okay. Testing composite component should therefore focus on showing that the component interface behave according to its specification, okay. We have the interface that provide function A, we have interface the function B, and then function A and function B, they are doing some kind of the job, right. So we need to make sure that that interface is what we call doing the job well, okay. So this is what we call a component testing, okay. Interface testing objectives are to detect the fault due to interface error or invalid assumption about the interface, okay. There are many interface, okay. There are many interface. One component can be 10 interface, okay, 20 interface. So we want to make sure the interface can serve, okay, without any fault or any error to the request or to the caller, okay. The type of interface type, there are many interface type, right. There are parameter interface, there are sharing memory interface, procedural interface, message passing interface. This is a kind of the interface that when we develop application. There are many kind of interface. Most of interface, they are about parameter interface, Okay, it's about data passed from the method or procedure to another. This is the thing that the interface that we are familiar. You write any kind of method or class. This is the parameter interface is the famous one that we always use it. Okay. This is the interface testing. For example, we have test case. Okay, the test case is a thing that we want to test. Okay, the procedure, the criteria, the data, and then the input that we want to test. Okay, and then we have the A, B, C. This is the component. Okay, the component or the function inside the component. Okay, inside the system. Okay, so system will provide the interface to the tester. So we test through the interface. Okay, through the interface to calling function A, to calling the function B, and to calling the function C to see that they will serve our need or not. Our what we call the system will serve the request or not. Okay, without any defect or error. Okay, this we call interface test. Okay, because interface testing is a kind of black box, so you cannot see the code inside. You just call and use it. Okay. You can call and try to test it. Okay. There are many kind of interface error. Okay, interface misuse. Maybe you wanna use interface A, but you connect to interface B. This is a very fatal error. Okay, because you don't wanna test about login, but you call to register. For example, this is misuse of the interface. So you have to be considered about this thing. Interface misunderstanding. Okay. You calling about login, and then but you try to test by using the registration component or registration test case, right? It will not be suitable, right? It will be something they will display some kind of error. Okay, timing error. Maybe you try to call the interface and then they always time out. Okay, they always time out. Something like this we call timing error. Okay, interface testing guideline. Okay, so you want to do what we call component testing through the interface testing. So we have to first is design test. Okay, second is always test pointer parameters with null pointer. Okay, we try to send without any argument or parameters to there first. Okay, design test with cause of component to fail. We try to design the test that made the component to fail. Okay, use strict testing in the message passing the system. So we try to strict testing mean that we try to test that something that with out of condition that that method or that interface can be handled to see the error. Okay, in shared memory system, vary the order in which the components are active. This is another part of the testing. Okay, this is another part of sharing memory system. You wanna test the interface testing guideline. Okay, this is a guideline that you have to follow. You want to do the test about interface testing of the component. Okay, design test. Okay, always test pointer. Okay, without null pointer, without any argument. Over there you test and see the error, it will be handled or not, and then try to design the component to try to make the component fail. Okay, then we display the error to you, and then we can take the error to fix our system, and then try to use the strict testing, mean that the condition that the component or the interface cannot be handled. Okay, something that unpredictable condition that the component that don't think about this is they will be the input of the test case. Okay, we call strict testing. System testing is about testing the whole system, that the system is integrated, working well or not. Okay, say that the system testing during development involve integrating component to create a version of the system and then testing the integrated system. Okay, system composed of a component, right? The component composed of object and class inside. So all things together, all components merging or integrating, okay, of component we call the system testing. Okay, so we have to make sure that the component that integrated component working well according to the situation or according to the specification and requirement. Okay, The focus is system testing is testing the interaction between component. The component is they provide the interface. We wanna make sure that the interface that they provide by the component is working, serving the request well. Okay, system testing check that components are compatible, interact correctly, and transfer the right data at the right time across the interface. Okay, system testing tests the emergent behavior of the system. The main point of the system testing is they try to test the component that the component that integrated already in that become a big or huge system, and then we test that the component can be worked with another component. Okay, this is a system testing. System testing and component testing. During the system testing, usability component that have been separately developed and of the chef system may be integrated with newly developed component. The complete system is then tested. There may be a component developed by the development team. They may be the component you purchase from outside that we call off the shelf. So we had to make sure that those components will integrated well and then without any error. Okay, so we have to make tests. That's why. Okay, the component developed by different team member or sub team may be integrated at this stage. Okay, system testing is a collective rather than an individual process. You look at unit testing or component testing, it's become the individual process, mean that they will test us only in that the component or in that the component for the component testing, right? In that object for the unit testing. But for system testing is collective, mean that there are many components inside the system, right? We wanna test that how when they collecting together to be a system, it will working well or not. Okay, it will work based on the specification or not. Use case testing. We can use use case testing to identify the system interaction that can be used as basic of system testing. In use case testing, in UML we have use case, right? We have use case that represent our what we call model of the system, right? We can use that to be the basic information for creating the system testing. Okay, its use case usually involves overall system components, so testing the use case force this interaction to occur. The sequence diagram associated with the use case document the component and interaction that are being tested. So we can use the sequence diagram to make to see the flow, the interaction between object, right? So we can use that as our information, our basic information to write the test for the system testing. This is, for example, of the weather station. Okay, weather data sequence chart. Okay, this is sequence diagram of the weather data. So you look at here, we have the object, right? The object that represent in line, okay, horizontal and vertical, that used to send and request and then respond. So we can see that the request there will plus with the method that request, and then respond will be respond by some kind of knowledge or information or the result, right? So we can use this sequence diagram to be our guideline, our data that used to write for testing the system testing. Example here, test case that derived from the sequence diagram. As we say that you can use the sequence diagram to write the test case. Okay, from this figure we have the request and response, right? So we can take this figure to write the test case. What will be start first and the middle and the will be end? What will be the result and unpredicted result or input and output of the testing? Okay, testing policy. Okay, it's difficult to test all things system all together. It should be some what we say, some part, okay, some middle thing that we use to test. We cannot test for all things inside the system. Difficult. Okay, so this example of the policy. When we do testing, there should be a policy that what the limitation of testing can do. Okay, for example, all system function are accessed through the menu should be tested. Okay, for example, this one combination of function where the user input is provided. There should be the policy, the thing that you want to test. It should be something could do some kind of condition. Not all condition. It will be difficult because it's impossible to test all conditions, right? So we have to limit it, and then we have to create some kind of a condition at test, and then it should be a kind of testing policy. There are modern technique to do the test. We call test-driven development. The short test-driven development is we call TDD. Okay. This approach is to program development in which you interleave testing and coding development. It means that you tests are written before code and passing the test in the critical driven of development. Mean that you write the test before you run the code. Okay, before you write the code. Okay, for example, you wanna do login system, right? You write the test first. Okay, the condition that you wanna test according to the requirement, and then you write the code and then pass the code to the test to see that the code is can pass the test or not. It's not, so we have to fix the error and then test again and again. Okay, you develop code incrementally along with a test for that increment. You don't move to the next increment until the code that you have developed pass its test. It means that you have to pass the test first, and then you can move to another development code. Okay, you cannot develop the code of another feature if that feature cannot be passed do not pass the test. Okay, this is the main point of the test-driven development. TDD was introduced as part of Agile. It's become the famous right now because it's a part of Agile. Because when you wanna do the Agile test, because the Agile test is something that when you want to add a feature, you suddenly can add the feature. There is no plan-based, plan-driven development process. You have no exactly how many requirements. It can be developing during the vehicle. Requirement can be added during the development. Okay, today you have 5 features. You develop 5 features, and then tomorrow you may add another features. So this is the test-driven will be the essential part, because it will make sure that your system will not collapse. Your system will not defeat of the code. Okay. This is the process of test-driven development, the generic process of test-driven development, or TDD. First is you identify new function. Okay, what function you want to write the code. Okay, and then you write test. Okay, and then run test. Okay, then you will see that the function is the test is the function is pass the test or not. If pass, then write another new function. Okay, if fail, implement the functionality and the refactor. You have to do refactor. If some feature that do not meet the test of TDD, you have to do refactoring. Okay, change the code. Okay, change the code and retest again until you got passed. Otherwise, you have to do again and again until you success. This is the process of test-driven development. The process activities, you want to do TDD, you have to start by identifying the function first. Okay, what thing that you want to do, okay, of the code, and then you write the test, and then you run the test, and then you implement the test, and then rerun the test again if the code is not successful. Okay, if they fail, you have to do refactoring, mean that you have to edit the code again and again until the functionality is pass the test, and then you can move to another functionality, or we call chunk of functionality or features. Okay, benefit of TDD, the first is code coverage. So every code segment there will be test well. Okay, we call code coverage. Regression testing will be reduce the regression testing because of what? Because it's incrementally Okay, incrementally test. You cannot be pass the test. You cannot develop new feature if you do not pass the test. So it will be reduce the regression test. Simplify the debugging because of test, right? You have to pass a test first, and then you can move to another feature. So there will be what we call easy to debug. Okay, easy to debug, and then it will be simple to debug because of what? Because of any feature they will relate to any test case. Okay, test case they will not let any code run without any test first. Okay, system documentation. The tests themselves are a form of documentation that describe what the code should be doing. Okay, the test will describe, that we call test case, right? We explain that what the system will look like. Okay, what the system will be, what the code should be doing, right? So we can write the document, system document through the test. Okay, because the test can be specified, the condition, the criteria, the test case, the data, the output that we want from the test. Okay, this is the benefit of the test driven development, or TDD. It can help a developer to reduce a lot of error. Okay, because the test is not start at the testing phase, but it start from the beginning. Okay, even it can start from the beginning before we can start to do coding of any features. Okay, regression testing is a test that system to check that the change have not broken previous working code. If we wanna make sure that our new feature will not be error, or will not be something that broken, that we have to do regression testing. Okay, regression testing to make sure that when you develop new feature and the previous feature still working well. So we have to do regression testing. By implementing the TDD, it can be reduced regression testing because of what? Because of new feature that you want to add, you have to pass the test first. Okay, in manual testing process, regression testing is expensive, but in automated testing, it is simple and straightforward. All tests are rerun every time a change is made to the application or to the program. So regression testing, when we apply with automated testing, it will run automatically. When you upload your code to the testing, it will test all things, okay, by itself, by using the automated testing. That's why it will be reduce a lot of error, and that will be a lot of what we call unpredictable defect. Okay, test must run successfully before the change is committed. Okay, before you commit new feature, so the test must be successfully run. Okay, release testing. Release testing is the process of testing a particular release of system that is intended for use outside the development team. You want to release, for example, you already developed the software, right? And then you want to release the software. This is another test that you have to do. You have to follow. There is we call release testing. The release testing usually done by the group of people. Okay, outside the development team. It can be user. It can be the tester outside. Okay. The primary goal of release testing is to convince the supplier of the system that is good enough to use the software. Okay, when you want to when you want to release the software, you want to make sure, you want to say to supplier that the system is good enough to use. Okay, you can use the release testing. Okay, this release testing is a black box because you cannot see the test process. So it can be done by normal people. Okay, by normal people that try to use the software, and then they can say that this is good enough or not for use in the real situation. Release testing and system testing. Release testing is a form of system testing, so it's a part of system testing. Important, it's different. Okay, because it's different. System testing is that it involved to the development team. Okay, but release testing is outside the development team. Okay. Requirement based testing. Testing that done by using the requirement specification. Okay, requirement based testing involves examining each requirement and developing a test or test for it. Mean that they develop the test case or test thing based on the requirement. Okay, scenario testing. Scenario testing. We have scenario testing is approach to release testing, whereby you devise typically scenario for use and use this scenario to develop test case for system. We use scenario to drive us to do the testing. This is the main point of the scenario testing. Okay, we have the long scenario that explain about our system, right? So we use that thing to drive the testing. Okay, the scenario is the story that describe one way in which the system may be used. Because the scenario will explain us that what system will be used according to this way, so we can use that scenario to make our guideline to test. Okay, this is example of the scenario of the main care system. Okay, there are sentence that explain that this system is doing and then action according to this one. Okay, process 1, process 2, process 3, and then the input will be the input, what will be the output. Okay, this is a scenario. According to scenario, we can select the feature test from the scenario, and then we can list what thing that we have to test according to scenario. For example, here we have authentication by logging on the system, so we have to test the authentication, downloading and uploading, home visit scheduling, encrypting, record, link the system for call, prompting, something like this. This is the scenario that we had to test to make the feature, to make the test fast according to the scenario. Performance test is about testing the performance and reliability of the system. It's about the non-functional requirement. We will see the system can be handle the situation or not. For example, there are many load of user, right? We design the one kind of software, how many load of user that can be handled, 1,000, 100, for example. It can be handled, it can be passed the performance testing. Test should be reflect the profile of use the system. Okay, performance test usually involve planning a series of tests. Okay, the strict testing is a form of performance testing. Mean that when you make the supplier or the user try to use the system, and then it means that you try to implement the strict testing, mean that the system with no test case, let them use the application and then see that is the result, that they are satisfied with the application or not, or program or not. User testing. In user testing or customer testing is a stage in the testing process in which user or customer provide input and advice on the system testing. I mean that this is exactly the thing that when we want to release our software, when we want to deliver our software, we have to make sure that our user and customer is satisfied with our result. We have to do user testing. Okay, they may use we may giving time for them to use the application, and then they will discuss about the result of the test. Okay, this is a kind of black box testing because users do not know about the code, but they can use the program via the interface, and then they can enter the data, the print output, and so on to see the application is working well according to their need or not. Then we call user testing. In user testing, we have 3 types. Okay, mostly 3 types. We have alpha, beta, and acceptance test. Okay, alpha is for user that working with development team. Agile process. User always working with development team, so they need to take this one. Okay, the beta is for user. Okay, the available, the more people that use this beta one. Okay, the people that many people, okay, not just only the user that work with development team, but people outside the team can take this one. And the last one is acceptance test. Is customer test a system decide whether or not it's ready to be accepted from the system developer and deploy in the customer environment, primarily for customer system. This acceptance test is the essential part of the testing, because customer will make decision that this I will accept or we reject this test or not. Okay. In user testing, we have three: the alpha, beta, and acceptance test. Acceptance testing. This is a process of the acceptance testing process. So first, you have to define the acceptance criteria. Okay, what the criteria that you will do for acceptance test. Okay, the second is planned acceptance test. Okay, the third is derived acceptance test, and then run the test, negotiate the test result, and then accept or reject the system. Okay, you see, define acceptance test criteria. Okay, actually they will follow the requirement, right? We have requirement 10 requirement, 100 requirement. They follow line by line. They will check one by one the requirement, that the requirement the test pass the requirement or not. Okay, and then they plan how many people may use the system. Okay, how many times to repeat the system. Okay, and then derive acceptance test, and then they try to run the test. Okay, and then they negotiate the test result. They may be, because of the software, they no 100% complete. Okay, no 100%, no error, right? There's some kind of error. They have to be negotiate with the user or customer that this error is reject or accepted or not. Okay, if some kind of fatal error, it should not be accepted. Okay, if something is just minor error or something, the small error that displayed something that or because small error, it should be acceptable or not based on the user and customer. Okay. In agile method, acceptance test is because of agile method, developer and customer or user, they are working together, so they always be a group, a team that always working together. There is no problem on this thing. It will be the acceptance test will be important in the agile method. Summary. Okay, software testing can only show the presence of error in a program. Okay, it cannot demonstrate that there are no remaining fault. Mean that software system can only show the presence of error in a software. Okay, in a program, it cannot be demonstrate that there are no remaining fault. There may be some kind of error inside, but the testing can test only the thing that present. Okay, the thing that present. Development testing is the responsibility of the software development team. Mean that the development testing is responsible by the development team. This is for a small group of testing. If there are big group of development, they may be separate. Okay, development testing include unit testing, component testing, and system testing. The unit testing is testing object or method. Component testing is testing about the interface, a group of object. Okay, the system testing is testing the integration between a component that try to combine to be the system. Okay, when testing a software, okay, we try to break the software by using the experience and guideline. Okay, we try to when we test the software, we try to break the software with several conditions, right, to test our software that is strong enough to defend the error. Okay, you should write your automate test. Okay, because it will be reduce a lot of effort, and then it can be reduce a lot of cost. Okay, and then it can make you automate. You no need to. It will take small effort for you. Okay, it can, and then you can run for long. Okay, TDD is a new approach. For TDD is a test first development, a new approach that can be used for testing. Okay, it will testing any function before you can write new function. Otherwise, you cannot be commit. Okay, you cannot be commit the code. Okay, scenario test involve the inventing typical usage scenario and derive the test case. Acceptance test is the user testing process. Okay, this is the summarize of the software testing. Okay, the main point of software testing is try to find any kind that error inside our application. Okay, try to see what the thing can be defeat our application, and then we can rewrite the code or refactoring the code to make it our application is make it more better, and then can be handling the situation better. Okay, this is the what we call is software testing. Okay.